Hello dear students, welcome back to your math classes. How are you all? I hope you all are good and doing well. So students, I'm your mathematics educator again here with a new chapter and a new concept. And today we have chapter number 7, which is algebra. So in this we are going in a mathematical world with the alphabet. So when we have alphabets in a mathematical word, that is called algebra. Let's discuss it in detail. Algebra is a branch of mathematics concerned the study of structure, relation and quantity. Together with arithmetic and geometry, algebra forms the backbone of mathematics. The word algebra comes from Arabic word algebra, which literally means setting or straightening of bones. So it means when we have to straightening our bones, that is called your algebra. That is originated from the Arabic word algebra. So in the context of mathematics, it means making something simpler or straighter. So we have to make it simpler and straighter. So now many great Indian mathematicians, Aryabhatta, Brahmagupta, Mahavira and Bhaskara Dwitya contributed a lot to algebra. In arithmetic only, numbers and their arithmetical operations such as plus, minus, multiply, divide occur in algebra. Numbers are often denoted by symbols such as alphabets A, B, X, Y, and we always consider the small letters. So this is useful because it allows the general formulation of arithmetical laws to reference to unknown numbers, the formulation of equation and the study of methods to solve this. Formulation of functional relationship. Algebra is a language just like French, Italian or German. In order to understand algebra, you need to learn how to read algebra and how to change plain English to mathematical talk and mathematical talk back to plain English. This is exactly what you are going to study in this chapter. So the introduction of this chapter is a little bit interesting, right? Here, what you have to do, you have to find out the unknown values we have. We generally use algebra to find out the unknown values. For example, I have a question for you. What number I have to multiply by 5 to get 30? So in that time, this is very simpler for you. You can simply say I have to multiply 5 by 6 and I'll get 30. But for example, a bigger equation we have. So by forming a algebra equation, by putting our operations, by operating with rules, you will get your answer in just quickly minutes. So that is whole concept of algebra. We have to read out, we have to understand the language of algebra in mathematical talk, and further we have to translate into in English as well. So before starting this, let's start with the parts of the algebra we have. So the first thing we have, that is literals. In this chapter on whole numbers, we have learned that 0 multiplied by 1 is 0, 1 multiplied by is 1, so 3 on. So in other words, any whole number multiplied 1 gives the same number. If we use the letter M for a whole number, we can say that M multiplied by 1 is equal to M. Now look at the following collection of numbers. You can observe that these are multiplies of 3. So 3 multiplied by 1, 3 multiplied by 2. So you generally represent 3 multiplied by n, and you can take any random number. So let us take up another example. Alicia is 4 years elder to Shweta. When Shweta was 1 year old and Alicia was 1. So 1 plus 4 is equal to 5 years. So when Shweta was 2 years old, Alicia will be 2 plus 4. When Shweta is 3, so 3 plus 4. So in that way, we can consider that the Shweta's age x and we add the values with it. So on, if we denote Shweta's age by x, the Alicia age is given by x plus 4. So literal means the letters which are used to represent numbers. So when we have to use alphabets to represent a number, that is called your literals. You can simply say the alphabets we have in algebra, that is your literals. Okay. Next, we have variable. So such a quantity which change its numerical value, it's called variable. So on the other hand, a quantity having a fixed value, it's called a constant. Numerals like 2, 15, 64, minus 2, 4 by 5, etc. are constant. So here what we notice, first we have literal, which means alphabets. Then we have variables, which are the changing numerical values. Then we have fixed value, that is called your constant. Now basic operation on literals. So the basic operations we have addition of literals. Sum of two literals x and y is written as x plus y. Sum of literals and a number say a and 3 will be written as a plus 3. Y more than z is written as y plus z. Sum of a literal x and itself is written as x plus x is equal to 2x. Now the properties of addition of literals. Commutative property. Addition of literal is commutative for any two literals x and y. So x plus y is equal to y plus x. Associative. We can change and we can make another group of our given numbers and our answer will remain same. Additive identity, whenever we add a literal into whenever we add a literal with 0, we will get the answer, the number itself. Now subtraction of literals, if a and b are two literals, then subtracting b from a is written as a minus b, a less than b is written as b minus a, or any literal a is equal to a minus 0, which is a. Just like subtraction of numbers, subtraction of literal is neither commutative nor associative. So those properties which applied on whole number subtraction, right, those properties applied on the literal as well. Now multiplication of literals, multiplication of a literal and a number, say 4 and x is written as 4x. Multiplication of two literals x and y is written as xy. Properties, commutative property applied, associative, existence of identity, property of 0 and distributive property. We already learned this property in our earlier chapters. So I hope so this is clear to you. In commutative property, if we change the order, answer will remain same. Associative property, if we make different groups, then our answer is also remain same. Existence of identity means whenever we multiply a number, given number with 1, the number itself is a answer. Property of 0, whenever we multiply a given number with 0, we will get answer in 0 only. Distributive property, it means if we have a number in bracket, so outer number will be multiplied with the both the numbers in bracket we have, or you can also multiply it like this. First you have to add your addition in the brackets, add them and then multiply with a. Okay, now division of literals, if a and b are two literals, then a divided by b is written as a divided by b. A literal divided by a number, say x divided by 5, so it written as x divided by 5. A number divided by a literal, say 8 divided by x, so it will be written as 8 by x. Now we have some examples where we have to use these properties and this concept. So let's get started. Write each of the following using numbers, literals and basic operation of addition, subtraction, multiplication and division. So sum of pq, so we can write p plus q. Product of 10 and x, so 10 multiplied by x. Subtract 17 from y, so y minus 17. So in this way you can represent your English language in mathematical way by using algebra. Write the following statements using numbers, literals and signs of 4 basic operations. The diameter of a circle is twice its radius. So we can take a diameter x or we can take r, and by multiplying it we simply represent as d is equal to 2r. The average of three numbers is their sum divided by 3. So we can take three numbers a, b and c. So the sum of it a plus b plus c divided by 3, we can represent it like this. Selling price is equal to cost price. So SP is equal to CP minus L. L is a loss. So in that way we can represent our statements into words. Now we have our exercise 7.1. Write the following using numbers, literals and signs of basic operation. Sum of x and y. So x plus 19. The sum of x and 19. So answer will be x plus 19. N increased by 2. So n plus 2. 1/6 of y. So 1/6 of y will be, how can we write? 1 by 6. And you can also write y by 6 because 1 will be multiplied with y. Okay. 9 more than quotient of a and b. 9 more than quotient of a and b. So 9 plus a b. Quotient of a by b. इसको रहने देते हैं, दूसरा example लेते हैं. So in after this you can solve 7 less than y. So 7 less than y. So y minus 7. 7 से 7 less than y. Y से 7 कम. हाँ ठीक है. So in same way you can represent your words into using by using your words you. So in same way you can represent your statements into algebra by using operations, literals and signs. Now write the following statements using literals, numbers and signs of basic operations. State what each literal stands for. The perimeter of a square is 4 times its sides. So you can represent 4 multiplied by L, where you represent side is equal to L. Now the radius of a circle is half of its diameter. So we are representing our radius is equal to r and half of it. So r divided by 2 is equal to d, or you can do like this also. Radius is equal to r, so r by 2 is equal to your diameter. So in same way, you can convert your statements into algebraic expressions. Now we have some word problems. Manju's salary is 2000 less than double of her expenditure. If her expenditure is X, what is her salary? So Manju's salary is 2000 less than double her expenditure. If his expenditure is X, so double of it is will be equal to 2x and her salary is less than it. So 2x minus 2000 is your statement. After this we have Prashant buys X pens and Y pencil. Cost of one pen is 10 and cost of one pencil is 2. So what is the total money spent by Prashant? X pens and cost of pens is 10 and cost of pencil is 2. So it will be your 10x plus 2y. This is the total cost of the total money spent by Prashant on pens and pencils. After this, Karan is twice as old as what Vinay was 5 years back. If Vinay's present age is X, what is Karan's age? Karan's is twice. So if we take Vinay age is Karan is twice as old as what Vinay was 5 years back. दूसरा क्वेश्चन ले लेती हूँ. Sudha traveled A kilometer on Monday, B kilometer on Tuesday, and 1/3 of the product of A and B on Wednesday. Find the total distance traveled by Sudha on 3 days. A kilometer plus B kilometer and the product, 1/3 product. So A by B upon 3, and we have to find out the total. So how can we calculate it? We have to take LCM of it. So we have 3. So 3A plus 3B plus AB is equal to 3A 3B 3A plus B plus AB divided by 3. This is the total distance traveled by Sudha on these 3 days. So in same way you can solve your rest of the questions you have in exercise 7.1. Now we move forward to our next concept, which is algebraic expressions. In your earlier classes, you have simplified expressions of the type of 2 plus 3 multiplied by 15 minus 7 is equal to 25 plus 65 divided by 5 minus 20, etc. These expressions involve numericals and signs of basic operations are called numerical expressions. An algebraic expression is a combination of literals and numbers using signs of basic operation. These are the basic operation we have: addition, subtraction, multiplication and division. For example, 2x minus 5 is 4x plus 5, a plus b by 6, p plus q, r, etc. You can also say that an algebraic expression is a combination of variables and constants connected by the symbol these. So parts of the algebraic expression separated by the symbols of plus are called terms of an algebraic expression. Our term can be constant, a variable, or a combination of constant and variable. We can separate our algebraic expression with the help of symbol plus, and it could be how can you convert your terms? It could be only constant, it could be a variable only, it could be a combination of constant and variable using operations of multiplication or division. So in the expression 8a plus 7b minus 6b, we have three terms: 8a, 7b and minus 6ab. A numerical expression can be evaluated. For example, 6 multiplied by 8 minus 2 plus 3 multiplied by 4 is equal to 58 by using your BODMAS rule. But an algebraic expression cannot be evaluated as such. An algebraic expression can be evaluated only if the variables take on some values. This will be illustrated with the help of the following example. For example, find the value of x minus 4 where your x is equal to 10. So what you have to do? First you have to write your expression x minus 4. You have to put 10 at the place of x because x is equal to 10. Now you have to subtract it. So 10 minus 4 is equal to 6. Evaluate 5x minus 3y where x is equal to 2 and y is equal to 1. So 5 multiplied by 2 minus 3 multiplied by 1. So 10 minus 3 is equal to 7. In the same way, you can solve your questions, your expressions by putting the value into your expressions. So what is your equation? When we use a equal sign, this equal sign, When we have equal sign between our expression, that is called your equation. Consider the statement 4 multiplied by 5 is equal to 20. You can at one side add the statement it's true. Similarly, you can decide that the statement 8 plus 9 is equal to 16 is false. So now look at the statement x plus 7 is equal to 10. Here x is variable and 7 plus 8, 7 and 10 are constant. So can you decide about the truth of this statement? So we cannot describe. So we cannot decide the statement for this. Answer for this, is it true or false? You can say that this statement is true or false only when you replace x by some number. Whenever you have to verify a statement having sign of equality or inequality, evaluate the left hand side and right hand side of the statement separately and then check the validity in between sign. Here we show confined to statement. So when you have a equation, for example, x plus 7 is equal to 10. So you have to check out both the side, the RHS and the LHS. If both are equal to each other, then the statement is true. If both are not equal to each other, then your statement is false. So what number I have to apply here for make it true? So if I put here 3, then my statement is true. If I put 0, 1, 2, then my statement is false. So whenever you have to find, so what you have to do here, thus an equation is a statement of equality which contains literal numbers, variables, a value of the variables which satisfy the equation. It's called a solution of the equation. You may know that if you simply have the expression of x plus 7, you can give any value to x and evaluate x plus 7 is equal to 10 or not. So write the following in the form of equation. So here we have a number subtracted from 45 gives now a number. We don't know which number it is. So 45 minus x is equal to 9. We can represent it as a equation. Sum of a number and 23 gives 64. So x plus 23 is equal to 64. We can represent it like this. Now state whether the given value of variable is a solution to the given equation or not. So 16 plus x is equal to 25 where x is equal to 9. So by putting this 16 plus 9 is equal to 25. So it means it is a solution for the given equation. Now find solution to the equation by trial and error method. Now we have to take any random number to classify is this correct for this equation or not. So this is called your trial and error method where we try random numbers by putting into our equation. So 2x plus 5 is equal to 9. So for this I first apply 0. So 0 plus 5 is not equal to 9. Then I apply 1. So 2 plus 5 is not equal to 9. Then I apply 2. 2 multiplied by 2 is 4 and 4 plus 5 is equal to 9. It means 2 is the correct answer. That is why this is called your trial and error method. Now we have our exercise 7.2. Express each of the following statements as an equation. Sum of a number and 5 is equal to 8. So sum of a number we don't know. So let's take that number x plus 5 is equal to 8. 4 less than a number equals 12. A number folds then 4 is equal to 12. Thrice a number is 24. So we don't know a number, so we take x and thrice. So we have to multiply is equal to 24. So in same way you have to convert this statement into your expressions, okay, into your equations. Now we have part 2, question number 2. Identify which of the following are equations. 5 minus x is equal to 1. So this is not your statement because if I change it 1 minus, identify which of the following are equations. This where we have a sign of equality, that is your equation. So it is a equation. It is a equation. So you have to classify that it is a equation or not, because the equation conditions are we have to put a sign of equality or inequality. If you have that kind of sign, then it is a equation, otherwise not. Now evaluate each of the following expression using the provided values. 7a minus 15 where a is equal to 3. So 7a minus 15, 7 multiplied by 3 minus 15. 7 3s are 21. 21 minus 15 is equal to 6. Next we have 2x by 3 plus 5 is equal to, where x is equal to 6. So 2 by 3 multiplied by 6 plus 5. So it will be equal to 6 are 12, 3 plus 5. So we have to take a LCM to add them together. 1, 12 plus 15 upon 3, and we have 27 upon 3, that is equal to 9. So same way you have to solve rest of the parts you have in question number 2. You just have to put the values you have into your equation and then you can simply identify your answer. Now in question number 4, state whether the given value of a state whether the given value of a variable is a solution to the given solution equation or not. So x plus 12 is equal to 20 where x is equal to 8. So yes, x plus 12 is equal to 20 and value of x is 8 plus 12 is equal to 20. So the given value is a solution of the equation. Y minus 11 is equal to 5. So yes, it is also a solution. 11 y is equal to 5 where y value is 15 minus 11, that is equal to 5. So yes, it is also a solution for the equation. So in same way you have to identify the given variable, the given value is a solution for the equation or not by putting the values into the equation. Find solution to the following equation by trial and error method. So x plus 11 is equal to 15. First I take value 0 plus 11 is equal to 15. So this is not a value. Then 1 plus 11 is equal to 15. No. 2 plus 11 is equal to 15. No. 3 plus 11 is equal to 15. Sorry, 15. No. 4 plus 11 is equal to 15. So this is a answer and this is a value of x. 4 x is equal to 4 by using trial and error method we can identify it. So in same way you have to apply your trial and error method. You have to start your counting 0 and you have to take it till that you get your answer which is equal to. Okay, now this is the end of your chapter students. I hope so you understood it very well. Now I'm going to meet you in your next class. Till that, bye bye, have a good day.